Hey guys, Alex from FastFitnessTips. I'm back this week with a really hot topic, one which I'm asked quite a lot. Just yesterday I got a question about which wheel set to use. Now we've already got a disc brake DB wheel set chooser on Patreon, but today I'm looking at non-disc brake, i.e. fast deep section aero wheel sets. If you want to upgrade your bike, probably the biggest, most effective, arguably most cost effective even, upgrade that you can make in order to go faster is to upgrade the aero wheel set. Now we're going to do a mega test, but I'm going to declare right at the front of this video, we are not going to go to the wind tunnel and test out 10, 20, 30, 40 wheel sets because somebody has already done it for us. And just as Specialized did the wind tunnel with lots of different options on your bike, and we summarized it, the top 10 changes you can make on your bike for free and the most marginal gains you can make on your bike. We are giving credit to Bikeradar for going into the wind tunnel, University of Southampton, and testing out 10 wheel sets with, it must be said, a fairly thorough testing procedure.
Super deep wheels offer some of the biggest aero gains that you can buy. So we got 10 of the best sets together across a range from 65mm up to an enormous 95. And we took them out on the road for some real world testing, and most importantly and excitingly to the wind tunnel at the University of Southampton, where you were able to gain some absolutely definitive data on what is the fastest for your money.
Now, I'm going to deconstruct what they've done, and I'm going to put my spin on what they did well and what they did badly. But I think give them credit at the start. Let's give them credit for what they did do. What they did well is they tested 10 separate wheel sets, fairly extensive testing, control conditions in the wind tunnel. They had a control tyre for nearly all of them apart from the Mavic CXR, which they allowed to use their own Mavic tyre. And they tested, to their credit, 2 yaw angles. And then they gave some kind of ranking, from top to bottom that you see here. Their ranking then is, first is the Envy SES 7.8. Second was the Head Jet. Third is the 995. Fourth is the Zip 808. Fifth, Vision Metron 8155. Sixth, the Mavic CXR 80s. And seventh, DT Swiss RRC 65. Eighth, Profile Design 78s. And ninth, Rovol CLX 764 from Specialized, surprisingly low there. And 10th, right at the bottom, and pretty disparaging comments from them on the Progress Space. So how did they arrive at that ranking? Well, essentially they looked at the drag and the watts to overcome that drag at quite a high speed. For some reason they chose 30 miles an hour, which will tend to exaggerate differences, because the higher the speed, the more, the aero effects become important. So they choose 30 miles an hour or 48 kilometers an hour. And what they're saying here is these are the reported watts that are necessary to keep the system going, i.e. to overcome drag. And that's the watts to overcome drag for the bike, the wheels and the rider. Given that the bike and the rider were static, i.e. controlled, it seems at first sight a pretty fair estimate. However, where they really dropped the ball is combining these 2 yaws, arbitrarily 5 and 12.5, to do a combined drag. So for example, they're saying here that the combined drag of the Mavic CSR is 410 watts plus 438 watts for 5 plus 12.5, which equals 848. But unfortunately, cycling doesn't work like that. You don't go out at 50% of your time at 5 degrees and 50% of your time at 12.5 degrees. This combined drag figure is pretty much nonsense, I'm afraid. However, their primary data from the lab, i.e. from 5 or from 12.5, is not necessarily invalid, albeit the differences are exaggerated. So here at Fast Fitness Tips, we like to deconstruct data. We like to look at data. We're somewhat data nerds, data geeks here. And what we've done for you is we've redone their analysis from scratch using wind average drag figures. Now, let me just explain this. We need to go back to basics with yaw. Now, if we're talking about yaw, when you're riding along on your bike, you're going along at a certain speed and you might have a slight crosswind. Well, because you're forcing yourself into the wind going forward, the combined wind vector is actually a product mostly likely of your speed, because your speed is faster than the likely wind speed, 5 or 10 kilometers per hour. However, that doesn't tell you what the average wind speed is. Numerous sites have tried with extensive calculation to model average yaws, typical yaws, and of course it does matter which direction you're heading in, whether you're doing a loop, but for the purpose of today, I just want to know what's the average typical yaw, what's typical yaw in typical riding conditions for a typical rider. So this is actually becoming increasingly known because of these new technological environmental capture devices that we've been able to put on the front of the bike and then go out on a typical ride and then collect the weather data, including the wind, the ambient wind, the ambient temperature, etc. And this has been done by numerous small studies now. It's been done by Flow Cycling, it's done by Mavic, it's been done by Trek. And yes, it does depend on the speed as shown in this chart here. So without further ado, if we were to look at these typical yaw angles and work it out in percentile terms, it turns out that the typical yaw angle is not far from what DJ Connell, blogspot.co.uk, modeled a few years ago. He actually said around 6 degrees. Well, the typical yaw angle for average riders seems to be around 4 or 5 degrees. So that's in most conditions, with most decent road cyclists. If you were going faster, for example, on the TT bike, your typical yaw angle would be even narrower. So it might be 3 to 4 degrees, for example. So given that typical yaw is around 4 or 5, we can actually base all of the mathematics of these wheels around their 5-degree yaw. But if you really were interested in extreme wind conditions, and by that I mean a wind condition that you encounter less than 10% of the time when riding, statistically, 10%, 12.5 degrees coming from either direction, left or right, then yes, I'll model that for you as well. So now let's go into the clever bit, guys. Now I'm going to show you how you can leverage the data that Bikeradar have collected to find the optimum wheel set for you. Now, to find the optimum wheel set for you, you've got to answer a few basic questions, and basically we are revolving this around 3 parameters. They are the wheel cost, the wheel weight, and the wheel aero or drag. And that's because we know the cost, we know the weight, and we know the aero or drag. I want you to bear in mind the aero or drag, as previously mentioned, isn't really a fixed number in watts. It's really a relative position because we don't know exactly the wind tunnel setup, we don't know the rider setup, we don't know necessarily the bike or tyre setup. Indeed, they varied the tyre setup, didn't they, for the Mavic versus the other wheels. So consider the wheel aero or drag numbers as relative. In fact, that's what we're going to do to analyze this, and I'll show you how we did it behind the scenes in a second. We're using each stat on the wheel as midpoint and then relative to the midpoint. Alright, more of that later. So basically what you can do here is enter in question 1, question 2, question 3, what's your relative importance of that factor? So for example, wheel cost. Is it very unimportant? In other words, money to no object, put a 1 or a 2, let's say. Or is it extremely important? You're trying to save money, put a 9 or a 10. And the same for wheel weight. If you're a climber, you want to emphasize wheel weight, put 8, 9 or 10 in there. And if you're a time trialist and drag is important, put an 8 in drag, but put wheel weight down to 3. And what that's doing behind the scenes is carrying out multiplication to rank in relative terms the emphasis on each of those factors. And so you will get here a live dynamic rating of the best choice. So for example, here it says NVSES, your custom ranking is a 10. But let's put wheel cost down to 1. You'll see that Envy goes up to 6 there because it's the most expensive wheel. If we downgrade the weighting on cost, then obviously it's going to uprate in that list. So we've got here the Bikeradar final position, we've got our FastFitnessTips position, and then we've got your custom position to choose between those 10 wheels. And you can choose between them at either 5 degrees or 12.5 degrees. I suggest that you stick to the 5 degrees for reasons I've already said. Now I'm not going to stop there because some of you won't be satisfied with seeing, oh, those are the results. You want to see the actual data, the actual calculation. And okay, this is not for everyone, but I'll put this sheet up for you in the description below. So here's how we do the calculation, guys, if you really want to know. What we're doing is we're just finding the mean point, like the mean average price, the mean weight, the mean drag position. And then we're rating them on percentage terms, for example, let's take the Specialized Roval CLX64. So in percentage terms, in price, it's 2.8% under average. In terms of weight, it's 8.9% under average. And in terms of drag, it's 5% over average. Okay, then all we do is we take your multipliers and then we multiply them up. That's your custom multiplier. And this is the way we've done it. We've basically done a multiplier if weight, price, and drag are all equally important. If weight is emphasized 5 times compared to the others, if drag is emphasized 5 times, and if money is no object. We've done the ranking for each one, and then we've summed those, and that's our final position ranking. But your custom ranking is based on your personal figures. So in summary, guys, we've taken that Bikeradar awesome 10-wheel test, of which the primary data is probably valid. We're emphasizing it more for 5 degrees yaw than 12.5 degrees. You can really almost throw out the 12.5 degrees yaw data, but if you want to look at it, it's in the spreadsheet on tab 2. We've enabled you to do a custom weighting depending on 3 factors. Obviously, if you want to take into account quality, you want to take into account road feel, you're going to have to do that subjectively on top of these findings in addition to that. In other words, those quality markers are in the eye of the beholder. And then finally, we've presented all the data behind the scenes so you can look at it in great detail if you want to take a deep dive into our methodology. We put all that up on this site for free. So this is a controversial area. I'm sure you'll tell me whether you agree with my method or not in the description below, guys. And I don't want to say I'm taking credit for anybody else's work. I'll say one final time, this is their data. They did a primarily awesome job, but we think we can do better by tweaking the interpretation. So this is our result, our final result of what is the top 10 best wheels that you can buy based on a restricted choice of 10 tested in the wind tunnel by Bikeradar. And they are from bottom to top: the 995, the NVSES 7.8, the Mavic CSR 80s, the Profile Design 78, the Zip 808 NSWs, the Vision Metron 8198, the Roval Specialized CLX Rapide 64, the DT Swiss RC 65, second place, Progress Space at superb value, and then at number 1, Headjet 6090 Black. That is our recommendation based on the data to hand. Boom, guys, that's the best I can do for today. Stay tuned to Fast Fitness Tips. Have a look at our Patreon site. Stay safe out there. As always, have a great ride.